Former environmental compliance manager for a mining company in eastern Kentucky, Mark has over a decade of experience in regulatory compliance. He has worked with state and federal regulators, including US EPA, Kentucky Division of Water, Kentucky Division of Mine Reclamation and Enforcement, United States Army Corps of Engineers, Tennessee Department of Environment and Conservation, Office of Surface Mining Reclamation and Enforcement, and the U.S. Fish and Wildlife Service. Okay.
Thanks, Katie. Good morning. As everyone knows, in the mining industry, when you're, especially in abandoned areas or mines that have been idled, one of the main things is data collection. And what we found is we've been able to do remote monitoring. It's continuous monitoring on these sites. We found that any parameter, for the most part, that can be measured in the field can be measured continuously with remote monitoring services. Types of monitoring that we can do when it comes to water quality and flow. We've been able to do flow meters, several different types, water level meters, pH meters, turbidity meters, temperature sensors, conductivity. Like I said, basically any parameter that can be measured in the field can be connected to a system to be measured continuously. The benefit to that is you're getting your data, you're getting a big picture of the data instead of just a snapshot of going out and maybe doing a field check or collecting a sample, and you're getting a small picture of what it is now. With systems like these, you're getting a big picture over a longer amount of time. Weather and air quality can also be measured in these remote areas. Another benefit to that, besides just the data and the amount of data you're getting, but in most of these sites, you don't have people on site every day. So when you're sending someone out, you're sending them to a remote area, you have safety concerns. Systems like these kind of negate the safety part because you're not having to send anyone out. All you have to do is just get your data from anywhere basically you have an internet connection. With MPDS new permits being issued, we're noticing that a lot of emphasis is being put on accurate flow. A lot of states are setting up their total maximum daily load for sedimentation, and to enable to get this, they need to know a better amount of flow that's coming off of these mine sites. And also their total suspended solids or turbidity is another big one as far as monitoring the sedimentation. Another big one is groundwater level with monitoring wells. There are systems out there now that can be placed in situ and will monitor the water level continuously. And what the benefits of that is the data you can show trends like during different times, different seasons, different weather patterns, how the groundwater level changes. The benefits of long-term monitoring is it allows, the policymakers, it allows the operators to get a big picture of what their operation is and be able to figure out where their issues lie and what they need to do to, fix their issues if they have any. And it'll also help track progress toward reclamation goals. And we feel this could be very beneficial on abandoned mine lands when you're trying to get final reclamation done. Most of these systems, if it's an actual remote system, we use telemetry to transmit the data. Basically, data is collected in the field and then it's transmitted. And we've found that these systems can be placed in the most remote locations whatsoever with the use of satellite technology. The data can be transferred back to our servers instantaneously. A lot of times we get questioned, how do you verify your data? Well, there are several processes. We have at my company, we have a QA and QC program where basically it's a combination of using the factory calibration that's done on the meters and sensors. And also we have handheld meters and sensors that are EPA approved in most cases or fall under some sort of ASTM standard for calibration. We use those sensors to verify the data that's coming from the in situ sensors. And then we make sure that all sensors that are placed in the field are calibrated based on the manufacturer's recommendations. As part of this presentation, I wanted to include this case study. What we did is we worked with a client who has an operation in a very, very remote location. Here's some background on it. Basically, it's an old refuse site that is in reclamation, and the refuse has been capped, okay, but there's still water that seeps out of the refuse area. And the base pH of this water is anywhere from, we've measured it as low as 2, 2.5, 3. The highest without being treated we've ever seen it was a 5 pH. Okay, and the problem with that, they don't have a manganese issue, which surprises us, but they have an iron issue. When the pH drops, they have an iron issue. And so what they were doing is they were having to send personnel out every day, and they would drive one way about 45 minutes. They would check the pH of the water. If the pH was low, they have just a drip of caustic to treat the water with. So if the pH was low, they'd turn on the drip. They'd let it go. They would leave, go back to their regular jobs because there's no personnel stationed on site. So they'd go back to their regular jobs. They'd come back to the end of the day. They'd check the pH again. And then basically they would make a judgment call on whether to leave the treatment going, cut it off, and also they had to, take into consideration if it was flowing or not, because if it wasn't flowing, they didn't really have to worry about the pH, but, they had to make a judgment call there. Is it going to start flowing? Are we getting rain? Things of that nature. So here are the problems we identified. The untreated water has a very low pH. The pH is only measured once a day, most of the time. The pH was measured using the pocket pens, that you get from Hack and other companies. And the permit requires that the pH range be 6 to 9. It's an inactive site, so like I said, they have no employees there, and it's about a 45-minute drive one way to get to the site. Okay, some other identified problems is on their chemical dosing, they had no way to control it. Like I said, it was a drip. They just turn a valve, and so sometimes they may, boost it too much. And if anybody's ever been around using caustic, the more you put in it, it ends up, it's not very good for the environment. It does what it needs to do as far as boosting the pH, but putting too much of it into the environment is not a good thing. Now I say, without traveling to the site, there was no way to stop the treatment, and they had no way of knowing what the pH was. And the caustic's expensive too. So under the MPDS permit, if the pond's not discharging, there's no requirement to treat the water. So if that's where they had to make a judgment call. So a lot of times they were wasting chemicals, or the pond would start flowing without them being treated. So then they're in violation of their MPDS permit for the pH of the water. And here again, if the pond stopped discharging while they were using the chemical treatment, they had no way of stopping it or knowing that the pond had stopped flowing until, and this was, if you have weekends or holidays, you could go several days without anyone being on site. So you're just feeding chemical into the water for no reason. So we came up with the solution. We installed a remote pH monitor and a water level monitor at this outfall. And the way we set up our report, the water level meter we designed the report to show what the distance was between, not just what the water level was, but what the water level was in relation to the discharge pipe. So when the customer gets their report and they log in and see it, they see that the water is a foot from discharging, okay? So we put these systems in, and we left them in for, they were in almost a year when we started doing this case study. This is a sample of the data. The data collected can be exported out to Excel, and you can do your charts, and can be used for reporting. And like I said, it gives you a big picture. And we just did like a few days here just to kind of show the data and how it would show up on a graph, looking at the pH. And then this data we can narrow it down to hourly data if you needed to see, how it changed from like if you weren't treating it, when it started treating. And this gives the client or the customer, or the operator, a chance. He can look at this data over long terms, and he can see, if there's certain times of the day, if there's certain, seasons, certain weather patterns, certain, all this information when, he really needs to be concerned. On top of getting alerts with the pH, the system also sends him alerts if the pH drops to, I believe we guys said if it drops to 6.5, he gets an alert. If it's flowing. If it's not flowing, he doesn't get an alert. But he can log in at any time and see what the water level is and what the pH is at that time. This is some of the benefits of that. He has 24/7 access to real-time data. This pH meter, it takes a reading every minute. So he's able to see it, and when he downloads his data, he can break it down. He can look at it every minute if he wanted to. System alerts for any parameters of concern. On any of these systems that get installed, alerts can be set up if you have a parameter. If it's a rain gauge and if you get a certain amount of rain within a 24-hour period, if you want to check your ponds or your outfalls or your dams or ditches, you have that. So that gives you more control, better decision making, employee safety, which is a big one. So now this client is not having to send his crew out, driving 45 minutes one way twice a day. And, so that's all that time on the highway. Plus, they're able to use them to do their actual jobs, on site. So they're not having to go and take care of this every day. So then you have transportation costs, hauling the chemicals to the site. And not just that, but the cost of the chemicals. This is a cost comparison for 6 months. Okay, they were using the cost. It came in 300-gallon totes. Okay, so before we installed the system, they were using around 7 totes every 6 months. And with the cost at that time when we did this, and it's probably more than that now, the cost was about $15,000 for those 7 totes. After we automated the system and they had better control over it, they only used 3 totes of caustic, and it's the same water. So that cut their cost down to $6,600. Okay, the cost of this remote monitoring was only about $2,700 for that same time period. So when you figure all that in, they're saving about $12,000, and it may even be more than that now with the cost of everything going up. Their total savings is about $12,000 a year. So even when, there's systems out there that can be bought and installed by the operator, but most of those systems require either they use their proprietary telemetry, or you have to make a trip to the field. It may collect data 24/7. You still have to go out and retrieve the data. A lot of them have a USB interface where you download it to a computer, and then you go back to your office and then you look at it. And that is an option depending on the operation. Like I say, deployment options. You can purchase equipment, and your sensors and meters can be installed by whoever purchased them, by the operator, by the agency. Or you can use a turnkey service, which is what we happen to offer. And all monitoring and sensors, equipment, we install it, we maintain it. The end user, whether it be a government agency or a mining company or whatever, they don't have to touch it. All they have to do is just collect their data. This is some pictures of the site. You can see you can't really see the water level meter because it's underwater, but the float thing there, that is the pH meter. We've got it suspended there, so it's right by the discharge pipe, which you can see. The discharge pipe's right there. And so we're getting the best reading right before it discharges. And you can see this pond is actually a series of ponds. On the other side, there's a bank there, and the water is piped. And then they have a series of these curtains to try to clean up the water before it's leaving the site. And that is our system there. It's totally self-contained. No electricity is needed. Everything's done either via cellular or satellite to transmit the data. Some other examples of remote monitoring. This is a coal mining operation, and they wanted to get a better crack on how much water is leaving their site for their flow instead of just doing the normal go out. Well, it looks like 100 gallons a minute. So we were able to put in flow meters to calculate that flow. And the issue we found here was the downstream area, is very flat. So what was happening is the water was backing up into the channel during times of heavy rain. So we were able to put in a velocity meter as well right there, so they know that when they look at their data, if the CFS looks weird, they know it's because the water is backing up, and their permit allows for them during flooding situations that they can have alternate limits. This is a groundwater well. The operator is required because it's very close to farmland, as you can see from the corn there. There was concerns about blasting actually affecting the water level at this site, so we were able to install a water level meter in the groundwater well. So now they have 24/7 access to the data, so they can see. They can look at, this is when we blasted, this is what the water level did here. So it gives them a big picture of what's going on their sites. This is another situation. The state, in this situation, the state wanted more accurate flow instead of just estimates. So, and this is what the customer was dealing with. They had two pipes discharged into just a rock channel that ran off site. And it was really almost impossible for them to really get an accurate flow monitor or flow amount. So we were able to install a partial flume and a water flow meter to get an accurate flow for them. So it went from what the other picture showed there to now the flume catches all the water, whether one pipe or both pipes are discharging. This is an example of the customer was being required to, they didn't really need a flow amount. They didn't need a quantity. They just needed to know when the pond flowed for a couple reasons. It told them when to take a sample, and also told them when to, they were able to calculate, how many hours per day that the pond flowed, which was what was being required by their permit. So what this is here is just a water detection probe that's in that pipe. So when the pond flows, the water flows through the pipe, they get an alert that the water's flowing. And then the system calculates that you had positive flow for 6 hours a day or whatever it is. And then they're able to look at that and then report those numbers so that they can set up their TMDL program. This is on an impoundment where they were having trouble with very high TSS, and this client was being required to monitor. So this is actually a turbidity meter. So at this decant pipe, when the water flows, they're able to see what their turbidity is, and then they can make changes downstream if they need to put it into a holding pond or if they can let it just go off. This is just other pictures of different types of monitoring that's available out there, and I've ran out of time. Thank you.